afternoon, everyone. You can hear me okay? Thank you so much for joining me. This is my first time in New York City, and I've been walking around like crazy. It's the most beautiful city in the world. Don't tell that to London because they might kick me out. But so far, I've loved it. So thank you for having me in your city, and thank you for having me at your conference. As Daniel mentioned, we're going to talk about serverless today. And before we do that, can I get a show of hands? How many of you are familiar with the concept? Almost the entire room, or maybe 80%. So I'm happy to hear that. I'm going to skip some of the intro so that we get the other goodies. The talk is hop on the serverless adventure, and we're going to do that by looking at how we can build NodeJS APIs using serverless, because that's one of the easiest use cases that we can get through, and it can get everyone started quite easily. Okay, so before we dive right into it, I want you to take a second and think about Twitter. And think about Twitter in terms of scale. So Twitter right now, it has 330 million users. And if we think about that in terms of tweets, that means that every second, 6,000 tweets get created. And that means that every minute we have 350K tweets created. And in total, that's 200 billion tweets a year. And imagine if you have a power user like Lady Gaga sending out a tweet to all of her followers. That means a lot of work for Twitter. And I just want you to think, what if the Twitter founders knew about these numbers and they just froze thinking about scale? Because those numbers are not very easy to achieve, right? And when you just get started with an application or building an application, you kind of try to answer all of these questions. And if you had in mind all of these numbers, I think it's quite hard to just get started. And that's basically me with every single startup idea that I've ever had. I just paralyzed. And that's actually the reason why I like serverless. It allows me to get started really easily, just build applications, build the next Twitter, and I don't have to keep in mind things like, how does my application scale? How do I program for that? Because already the cloud provider is doing that for me. My name is Simona, and as Daniel mentioned, I work as a cloud developer advocate for Microsoft, where basically my role is to make sure that JavaScript is a first-class citizen in the cloud. So if you have any complaints or any compliments for Azure and the work we're doing with JavaScript and with the web, do make sure to reach out in person today, but also on Twitter at Simona_Cotin. I'm there to help you. I'm there to answer your questions. Cool, so serverless. As we figured out, most of you already know what serverless is, but just quickly, so that all of us are on the same page, serverless applications are basically applications that either depend on third-party APIs, APIs like Auth0 or database like as a service. But also, whenever we're building applications, we cannot just depend on third-party APIs, right? We need to have some code that's specific to our application. And that's what we would call custom code, and that's what is known as function as a service. And we're actually going to focus mostly on the second part, which is function as a service part of serverless. So there's a few things that we need to know when we're building serverless applications. The first part is that we're reacting to events. So we're writing code that reacts to events. And the types of events that we can react to are things like an HTTP request. So whenever an HTTP request is made, that's actually an event that we listen to. And our code that might be stored somewhere in a storage account, once we get that request, we're going to make sure to take that code and deploy it in a container. So that means that we still have servers, right? We just don't have to manage them. So we take that code, we push it in a container, we install all the dependencies that are needed to run our code, and then we fulfill the actual request. That time that we take from deploying our code from the container to the actual from the storage account to the actual container and installing all the dependencies is something that you might have heard about, which is called cold start. We're going to talk about this in a bit. But just so you know. And then other types of events that we can listen to are maybe a file that has been uploaded on a storage account. We want to make sure we save some data in a CSV file, someone uploads it there, and then we have to process that data and save it in a database. Another thing that's important about serverless is the fact that it auto-scales. So no matter how many users you might have 0 or you might have 10, which is not ideal, but it can happen when you're just getting started with your application, and then you might jump to 1 million users. The cloud provider will make sure to spin up as many instances required, as many instances as you need to serve all those requests. And this means that our code auto-scales, our application auto-scales, and then you pay as you go. So you only pay for the amount of CPU and the amount of memory that our code is running. And that means that if you have only one container running, consuming very little memory, you're going to pay nothing probably, because all serverless providers actually have a free tier which accommodates a lot of requests. Cool. Another thing that's important to know about serverless is that we have an execution time limit. So a function is time bound to either 5 minutes or 10 minutes. So whenever you're building serverless applications, you need to make sure that your code runs within that time limit. Your functions are very well defined and granular. Functions are stateless because we don't know after 5 minutes where your new request is going to end up running. You should never rely on data being saved in between runs. So you have to make your function stateless, your code stateless. And cold start, which I mentioned earlier, happens because our code might not be running at that time, and we have to spin up those servers for you, and we have to make sure that your code, all your dependencies are installed. There's quite a number of serverless providers. I don't have all of them listed, but from Azure, you can try out Azure Functions. We have Amazon Lambda, Google Cloud Functions, Auth0 Web Task, and IBM OpenWhisk. The first one, Azure Functions, and the last one, IBM OpenWhisk, both of them are open source. And what that means is that you can go on GitHub, download the code, and then run it in on your machine. Also, what that means is that the runtime that you're going to run on your local is actually going to be very similar to what we have in the cloud. So that means that the development experience is going to be very similar to your production experience. Okay, and today we're going to look into Azure Functions. And what I've done here is basically I've answered some of the most common questions that we know how to do in a traditional environment, but we might not know how to do it in a serverless environment. And one of the first one is actually, how do I create a project? How do I get started? Which are the tools that I have available to create a new project? How do I debug and run locally? Because this is very important. We are all developers here, and we want to write our code in our local. We don't want to write code in the browser most of the times. How do I install NPM packages? This is again a very simple question, but unless you've tried it, you might actually not know how to do it. How do I connect to a Mongodb instance? Well, most of the times we don't only write code that doesn't interact with anything else. Most of the times we're connecting to a database, we're connecting to other APIs. So how do we connect to that database? How do I save my environment variables? That's another important question. We don't want to expose our secrets on GitHub or anywhere else. We want to be able to use the same pattern as we do with Express.js, for example. How do I read data from Cosmos DB? This will make sense a bit later when I'll dive into details. Again, this is related to connecting to other resources or other data sources. How do I configure REST-like URLs? This is important when we're building an API, a web app. We want to make sure we know how to use that URL pattern that we're used to in our applications. And finally, we've written all this amazing code that does a lot of stuff in our local, but then we also want to make sure that we can deploy it to the cloud. So how do we do that? So is everyone ready to answer all of these questions? Yeah? Yeah. Awesome. Cool. Okay, let's start with what are we building. We're basically looking at this web page, which is just a single page that lists cute puppies, and we can create puppies, we can edit puppies, we can delete puppies. Nobody wants to do that. But we have the option. So this is your traditional CRUD operations, which we can have started. So this is what we're looking at. Okay, and then we can get started. How do I create a project? We have multiple options. As I mentioned, we can use either a browser, and that's your option in the middle. With Azure, we have this thing called the Azure portal, and you can just go there and create a new function. You can test your function right there, right in the portal, write the code, and then it's already deployed, so there's nothing left for you to do. That's great when you're not working in a larger team. You can easily get started in the portal, but ideally when you are working with a bigger team, you want to make sure that you have some form of local development. And that's where Visual Studio Code comes into play. As you can see, I'm using a Mac, which means that Visual Studio will actually not work on my machine. So Visual Studio Code is the open source and multi-platform version of Visual Studio. And then another option to create functions is using the Azure Functions CLI. So if you're a command line type of person, you can just create new functions using the CLI, deploy them, and do everything that you can do in the portal as well. Awesome. Which one do you prefer? VS Code? Awesome. My favorite tool is VS Code, so that's what we're going to look at. And one of the best things that has ever happened to VS Code is extensions. And there's this thing called the Azure Functions extension. And with Azure Functions extension, we can create a new function. We can create a new function app, which groups more functions. And we can also deploy a new function. And I'm going to go ahead in my IDE and start doing all of that. So before this presentation, I actually ran into a priority one critical bug. My demos were not working, panic attack. So hopefully, fingers crossed, everything will work now, and we can get all the demos done. So this is VS Code, and to get to the Azure Functions extension, we need to go on that icon, which is the Azure icon, and then we have listed here some of the extensions that we have installed. In my case, I have Azure Functions, App Service, Storage, and Cosmos DB. So I'm going to go to Azure Functions, and the first thing that I'm going to do is click this folder button, which creates a new function app. And it asks me where do I want to create that function app, which is the language that I want to use. So in this case, I can either choose JavaScript or C# or Java. These are the languages that are supported in my local environment for Azure Functions version number 2. So I'm going to go ahead and use JavaScript. And what this has done, it has created a new folder for me, which has the VS Code debugging configuration. It also has this host.json file, which allows me to configure more global settings for my function. And then I also have this local.settings.json file, which is going to be the place where we're going to save our secrets. Okay, cool. The next thing that I have to do is create a new function, and I'm going to use the same folder. And now I have to decide what type of event do I want to listen to. So as you can see here, we have HTTP triggers, which listens to HTTP requests, blob trigger, which listens to files being uploaded in a storage account, queue trigger listens to messages added to a queue, and then timer trigger is like a cron job. So you can run tasks, you can run code every day or every 2 hours or every hour. Okay, so in our case, because we're building an API, I'm going to create an HTTP trigger, and I'm going to name this Get Puppies. There's different levels of authorization. This will basically create if I'm choosing anonymous, my URL is going to be public for everyone. If I'm choosing function, I'm going to have generated code, and everyone who calls my function will have to use that code. And for admin, I've never used that one. So this is the function that has been generated for us. And this is the code. It's index.js. Before we look at the code, actually, let's have a look at what has been generated. So we have a new folder called Get Puppies. The name that we gave to the function, and then this has created for us 3 different files. Function.json, and this is where the configuration for our function is. It's a JSON object that describes our function. So we can see things like the options that we've selected earlier, like what's the authorization level, what type of trigger have we created, and what's the direction of the binding. So are we listening to an input request, or are we talking about an output binding, which is what our function is going to return? Both of them are HTTP, and we can name these parameters so that we can use them later. The request is going to be rec, and the response is going to be res. And then from there, in index.js, this is where our actual code is going to be. And it's in this case, because it's JavaScript, it's a function that receives 2 parameters. The first one is the context object, and that's the object that we're going to use to interact with our runtime. So we can do things like log information, we can access all the bindings that we have defined, and we can log information. So we can see here that on line 2, I am just logging information. And then on line 4, I am checking whether my request object contains a name. And if that's the case, I'm going to return hello world. And if that's not the case, I'm going to return an error on line 11. So I'm going to set the status to 400 and pass on a message. And then when I'm doing context.done, this is where I'm telling my runtime that my function has finished running. So it will stop. I will not pay for the CPU and memory anymore. Okay, cool. Is everyone ready to run this in our local? Yeah? Woo! It's very exciting, especially if you've worked with serverless and you had to write it in your browser. Having this experience in your local is just, I think it's fantastic. I love it. Okay, so we can see here that our runtime has started, and this is what you would this is what you would use to run with your CLI. It's func host start, and it just starts the runtime and it deploys this new function. And I already have the URL, so I can go ahead back to my browser and access that function. So as you can see here, it's going to tell me that I have to pass a name, which is something that has been defined in our code. So if I go ahead and add name equals BuzzJS, it's going to say hello BuzzJS. Hello back. And the next thing that we can look into is actually debugging. So I've added a new breakpoint here by just clicking on the sidebar. And if I go back to my browser, I can refresh, and immediately it's going to stop at the breakpoint that I've set. And here, just like with any development experience out there, I can inspect variables, I can go through steps. So I can, for example, go ahead and change this. As opposed to having BuzzJS, I can say, hello, Daniel. and then step through. This is successful. I'm going to run, and then going back to the browser. Now it's going to be hello, Daniel. Fantastic. This is really good. But we're not here to see a hello world application, right? We want to go ahead and build an API. So I'm going to stop this. And the next thing that we want to do is basically implement the read endpoint. And I'm going to use one of the VS Code snippets. Is everyone here familiar with VS Code snippets? Yeah? So basically with VS Code, you can define snippets of code that you can reuse later on. So I've defined a snippet of code for reading puppies because I didn't want to spend a lot of time just typing. I want to show you to answer all the questions that we've seen earlier. And now we're just going to go through the code that I've written earlier. So the first thing that we need here is, in order to connect to a MongoDB database, we need to have the MongoDB package. And how do we import that? Well, we use NodeJS, so we just require the MongoDB package. But do we have it installed? I've just created a new project, right? We don't have it installed. So what do I have to do now? I have to create a package.json file, right? So I can go ahead and do that. And the important thing here is that I'm creating my package.json file at the root of the application. Previously, you would have to create a package.json file for each function that you have created. And that meant maybe a bigger cold start time, because for each function you had to take time to install dependencies, whereas now we can actually share the packages in between functions, which is great. So I created this function package.json file, and I have a helper file here where this is a package.json file where I'm just saying that I depend on MongoDB package. I'm saving this, and already my IDE is going to figure out that actually this package has not been installed. So I'm going to go ahead and run npm install right here in my project. And this is going to download the npm package. And while that's happening, which already did, we can go back to our application. So what do I have here? I'm requiring the MongoDB package, and then I'm creating an authentication object, which is basically allowing me to connect to a database that's deployed in the cloud. It's called Serverless. My user is Serverless Puppies, and the password, obviously, it's something that you should not see, but you're seeing right now. And then I'm using the Mongo client to connect to the Serverless Puppies database, which is a Cosmos DB database that I have in Azure. So you can see it here. I can go ahead in the Data Explorer and just see some of the collections that I have created in my database, and then the keys that you just saw earlier, I've just copied them from this connection string page. So I can just get the primary password from here, the URL, the port, and the username. Okay, and then the next things that we're doing probably shouldn't be news to a lot of the people that are familiar with Node.js. What we're doing here is we're connecting to MongoDB, and then if this is successful, I'm just selecting the admin database and then the puppies collection from that database, and I'm running the find method to get all the items in this database. And if that's successful, I'm just going to return the result and just close the database connection and call done on our context. Does this make sense to everyone? Yeah? Awesome. So we can go ahead and actually run this. Is everyone confident that this is going to run? I hope so. Okay. Does anyone see any issue with the code that I've written so far? Before that, Perfect. So we can see that we have the bestest puppy ever who loves humans. We have retrieved it from a Cosmos DB instance that's deployed in Azure, and we are writing code in our local. And this is in the Data Explorer. We can actually see that I have in my list of documents, I only have one item, which is the bestest puppy ever. But coming back to the code, what is the issue that you can see here? So if I were working with Daniel and I had to check in this code into GitHub, my password would be public, right? So then I have to move that to my local.settings.file, right? Because that's where we store secrets. So I'm going to go ahead and do that. I'm going to use my cheat sheet again, because it's a long list of text. So I'm pasting this here. So I'm creating a Cosmos DB URL variable, a Cosmos DB user, and a Cosmos DB password. And then when I'm going back to my function, I can replace here, instead of using this hard-coded string, I can just go ahead and use process environment and then Cosmos DB user. And then instead of using password here, I'm going to use process. As you can see, I'm a slow typer, especially when there's people watching. No pressure. And then here, I want to use process.env.cosmosdb URL. So now, instead of using those hard-coded values, I'm going to use the ones that are defined in local.settings.json. And this should run as previously. One thing to note here is that the runtime will always watch for changes in the actual code files, but it doesn't watch for changes in local.settings.json. So I'll have to restart my runtime here, and then I've just stopped it, and then I'm running this again. And in theory, because I just moved my secrets from one file to another, everything should work as expected. So if I refresh the page here, I should see the bestest puppy ever, which is correct. Awesome. Perfect. One of the other questions that we had was, how do we create routes, right? How do we create REST-like routes? Well, the good news is that we have this function.json file where we can configure our function. And we can define the setting that's called route. And here I can say that instead of using the name of the function that we've defined earlier, I can actually overwrite that name and define the puppy's route. And not only that, I can actually define a method that I want to listen to. So in this case, it's going to be the get method. Okay, so now instead of calling get puppies, here I'll have to run API puppies, and it still works as expected. So we've seen a lot of stuff. Maybe we can go through my slides and kind of make a summary. I've mentioned that the Azure Functions extension is the best thing that has ever happened to serverless. And then I have some backup videos because of demos not working all the time. But you've already seen how everything works here, so we're not going to go through detail. And then I mentioned that we're creating a new function, and that creates a new folder, which has 3 files. Very important. Then we have our package.json, we have our local.settings.json file, and configuration files that are specific to all the functions. And then here we have the function.json, which is the function configuration file, side by side with the index.json file. And you can see here that we're using the request object that's defined in function.json. We're using it in the function definition, and then the response again in the index.js file. That's how we access the variables that we've just defined. We've seen how we run and debug locally. No news here, right? Which is exciting because we want to be able to use the same practices that we've used throughout our developer's life. How do we install dependencies? We just create a package.json file and we run npm install, and that's going to work out of the box. How do I connect to a MongoDB database? Again, we're just going to use the MongoDB package and use all the goodies that we know already how to do. Obviously here you've already recognized which were the issues. We've moved that to local.settings.json, and then we used process.env in our code. Okay, perfect. So how do we actually deploy this, right? We've written a lot of code, but we actually want to make sure that all this code runs in the cloud as well. It's all in our local. And we can do this with the same extension that we've seen earlier. I just have to click this arrow button. And what this will do, it will first ask me, what code do you want to deploy? What's the subscription that you want to use? So who pays for this? And then it's going to list all my function apps that I've created previously. And because I'm connected to the same Wi-Fi that you are, my internet is not working fantastic. So I'm just going to use a function app that I've created previously, which is SC BuzzJS. And this will ask me, do you want to override whatever you have created previously? I'm just going to say yes. But you can already see what's a potential issue that you might have. Right? Daniel writes a function, he deploys it to the cloud, and then I write a different function and I deploy my function to the cloud. What will happen? I will overwrite all of Daniel's changes. And that's not ideal, right? When we're using this deploy directly to production from the IDE, it's actually a scenario where we're just testing our code. If we want to have a proper way of deploying code, we actually want to use a CI/CD type of environment. And we do that, for example, with Azure Functions. We can connect a function with our GitHub account. So we can authorize GitHub to deploy code to our function app. So whenever we're checking in a change, that's going to trigger a deploy to a function app. And that sounds better, right? You can go further and you can add Circle CI or VSTS to your development process, and you can run tests, you can build your application and deploy it to the cloud. Okay, while I was speaking, we can see that our function has already been deployed. What happened here was that my code was zipped up and just pushed to the cloud. And as you can see here, we have a bug. So the HTTP trigger URL contains the function name that we've defined earlier. But actually, we've overwritten that. We've created a route. So if I go ahead and try to access this, it's probably going to give me an error. Otherwise, the code I wrote wasn't great. Can anyone guess another issue that we might have? So we have defined in our local.settings.json our secrets, and my local code is using that. But what about the cloud? Do we have that? Is that deployed to the cloud? It's not. So that's a file that we're keeping in our local, and that's it. So this means that I'm going to have to go define those variables in my function app in the cloud. And there's multiple ways I can do that. I can keep using my development environment, so I can use VS Code, and I can go ahead to my function. I have access to the list of application settings. So this is listing the function apps that I have deployed in the cloud. So I can just define them here. And as you can see, Unfortunately, I forgot to delete these ones, so they're already defined, which means that our secrets should already be in the cloud. And I've updated the URL, and now our function is in the cloud, returning the same data that we've seen earlier in our local. Okay, was that exciting? Yeah? Awesome. I have very little time left. We're going to go through some of this because this is exciting as well. So how do I pass data into a function? We have this concept that's called bindings, and there's two different types of bindings. So we have bindings are basically data sources. How do we connect to data sources? So we have input bindings that we read from, and then we have output bindings that we write to, because those two actions are the types of actions that we want to be able to do. And some examples of bindings are the blob binding, the CosmosDB binding. CosmosDB is a database. I want to be able to read and write from a database. A queue binding, again, I want to be able to read and write a message to a queue. The way we define, previously in the initial version of functions, the runtime would contain all these bindings, whereas now in the second version, some of these extensions are external. This way our runtime is lighter. So in order to install, to use those bindings, we need to install some extensions. And this is how you would install the CosmosDB extension. You need to say the package name and then the version. And then to define a binding, we just have to go to our function.json file. And we need to define things like add to the list of bindings, the type of binding that we want to create. And then we define the database that we want to connect to, the collection that we want to read from, and then we can run a SQL query with this binding. We have to define the connection string because we need to be able to connect to that. And then the direction of the binding. So we're reading from CosmosDB. And then here we are defining the secrets again. And finally, as opposed to writing maybe 10 or 20 lines of code, this is the only thing that we need to do in order to read from a database. That's a single line of code where we are reading from context.bindings, and we are using the name of the binding we've just defined. And what this will do, it will run that query that we've seen earlier and return us in this object, it will return a list of objects. So I think this is really cool. It's very powerful and it's very simple to use. And these bindings are available for other Azure services like EventGrid or Event Hub. And then the team is actually working on allowing external or third-party applications or companies to define their own extensions. So that's like enabling everyone here to write their own extension and be able to use them like this. We've already seen how we do REST URLs. We just define a route. Another way to do it is using proxies. So this, if you have multiple function apps and you want to serve them with the same domain, you can use proxies, and they're quite simple to use as well. How do we do cores? Where in our local, we just have to define this host object with local cores. Everything is not recommended. It's not very secure, but for the sake of the example, I just added everything there. This is in our local, but then in our cloud, there's setting as well where you can set cores. How do we deploy it? We've seen that we can deploy from our IDE, and we can also connect to GitHub. And then we've seen a lot of demos. One of the things that I wanted to show, do I still have time? Q&A. Just 5 minutes? One thing that I wanted to show is that we have, so for monitoring functions, we're using App Insights. And we've just deployed this new function, right, which queries a database. And I'm not sure how many of you are familiar with artillery. Are you familiar with artillery? So there's 2 hands here. You can use artillery, which is an npm package, to run load tests. So artillery will allow you to set a number of users and a number of requests that you want to send to a certain URL. And because I want to test my function and see that it scales and that it spins up servers, I can just run this command, which basically uses artillery. It creates 10 users that will create 20 requests each to this URL that we've just deployed. And it will give you feedback immediately here on each request and how is it going. Hopefully the internet is okay. If I go back to App Insights, you can already see the number of incoming requests. So this is a screen that allows you to inspect your function. And then you can see here, this was the most interesting part for me, because obviously you have the question, do we still have servers? Well, you can go to this screen and see the number of servers that are currently running your code. So in this case, it's 5 servers, and if I increase the number of requests, it will actually grow to higher number of servers. And you have even the name of the server. So this is how you would monitor your function. Now there's 6 servers running our code. And this is the output from artillery, which is just telling us how many requests have we launched, and how long did it take, what's the latency. So we can even inspect things like how long does a HTTP request take, what's the average, what's my user's experience while using my website. Okay, cool. I think that was the last thing that I wanted to show. A quick recap. How do I create a project? Well, I use VS Code and Azure Functions extension. How do I run and debug locally? VS Code and Azure Functions extension is your friend. How do I install npm package? You already know this, which is great. It's the same good experience that you're used to. How do I connect to MongoDB? This is something you know already. How do I save my environment variables in my local using local.settings.json? How do I read data from Cosmos DB or from a third-party data source using bindings or using the extension? How do I configure REST-like URLs? Well, proxies.json is one option, but also the route field in our function.json file. How do I deploy to the cloud? Using VS Code if you're testing, and then GitHub or another versioning control system to have a proper system. Some of the resources that you might be interested to read on if you want to learn more about Azure Functions, Cosmos DB, triggers. John Papa and I also worked on a Pluralsight course where you can see how we build the entire API. If you want to have a look, it's available at that link as well. Thank you very much.